This one we're going to use Desmos to graph it, and we are looking at this one right here. The option here is D. So all you have to do is type that in. Find the vertex of the parabola and the axis of symmetry. So the vertex is h comma k. Remember, it's always the opposite sign of the h. So in this case, h is -3 and k equals -1. So it's going to be -3 comma -1. If we enter this graph into Desmos, we just click in the middle. So this is the middle. And it's going to give us the point. And then it says, what is the equation for the axis of symmetry? The equation is going to be the x value of the vertex. So it's going to be x equals -3. Find, the graph of the quadratic equation with vertex 0, comma, -2 is shown below. So this is the vertex, 0, comma, -2. It says find the range and the domain. So it's tricking you. Range is first and then domain. Range, when it opens upward, is going to be a bracket, whatever the y value of the vertex is. So in this case, it's -2, and then it's going to be infinity. If it opens downwards, it's going to be -infinity, and then whatever the y value of the vertex is. And then it's going to have a bracket. So in this case, our range is the y value, -2, comma, infinity. And then domain is always -infinity, infinity. Or it says find the vertex of the parabola by applying the vertex formula. So you do need to know the vertex formula because it's standard form. So x equals -b over 2a. And then to find the f of x, you would do f of -b over 2a. This is going to give you the vertex, but we can just graph it in Desmos. So just use Desmos. I have it over here on the right, and I just click in the center, and it's going to give me my ordered pair, 6, comma, -47. Please recall that a vertex is an ordered pair. In the air, the height of the ball is y in feet, approximated by y equals -16t squared plus 8t plus 3. Find the maximum height of the ball. This right here is the y-axis, or the y value of the vertex. And then it says, how long will it take the ball to reach its maximum height? This is going to be time. So this is going to be the t value of time. It's the horizontal axis values. This is vertical. Okay, so once I graph it, I can't see it, so you press the home key. Typically this works. You gotta know which is which. So the maximum height is gonna be 4 feet. The ball reaches a maximum height of 4 feet. It even tells you the answer. After blank seconds, round to 2 decimal places, 0.25. So read that. The vertex was 0.25, comma, 4. So it was time and height. Those are the values of these ordered pairs on this parabola. I also want to bring it to your attention, you should only be concentrating on the first quadrant. The first quadrant is the upper right-hand quadrant of the function because we're talking about units of measure, which is typically positive in math. The end behavior of the graph of the function, this is just asking what's happening on the left and the right. This is left and this is right. So the graph goes like that and it goes like that because this is going to be a positive, odd function. It's odd because of the 5, and it's positive because the 17, excuse me, the 17 right here is a positive value. That's where we get the positive from. So this means left as x approaches negative infinity, h, which is the function behavior, is going to approach negative infinity. And then on the right, as x approaches infinity, that's what's happening on the right-hand side, the function is going to approach infinity, right? Because this is negative infinity here, and this is positive infinity here. It's asking for the behavior, the end behavior of the functions to work it out. So all you need is going to be the base. This is the base, this is the base, and this is the base. So first we're going to find our zeros. So it's zeros of m. So m is the function, right? So it's going to say x equals 0, x minus 1 equals 0. So it becomes x equals 1. And then x plus 2 equals 0. So that becomes x equals negative 2. We're just going to list them. 0, comma 1, comma negative 2. Because again, this is the base. We only talk about the multiplicities based on the power that's given to us. That's the 1 multiplicity. This is the negative 2 multiplicity. The multiplicity is going to be the exponents of the base. So this first one had x squared, right? So that means my multiplicity is going to be 2. And then I had x minus 1 to the third. That's right here. So that means my multiplicity is going to be 3. And then my last one is x plus 2 squared. So my multiplicity is 2. This test is asking you for the numerical value of multiplicity. Please do not put even, odd, or whatever, because it does ask kind of like the same prompt in the homework. So these are the exponents of the base. Asking you to identify the function. So this is another multiple choice question. I typed it into Desmos. I kind of want to make this clear. So it's the second function I typed into Desmos. It's hard to see. There we go. Oh, you can scroll and let's try one more time. All right, so there it is on the bottom. It has all those zeros. So it's x minus 5, x plus 4, x plus 6, x minus 6, and then there was a 1 over 70. Now, I can't really tell what I'm looking at. So go to home. It doesn't really show, so I can zoom in. You have to be able to pinch the window. I know for sure it's not C or D because it doesn't look like it. So I just need to read the functions. This one is not it because this is all decimals. All right, your zeros here are x equals 15, x equals negative 4, x equals negative 6, and x equals 6. That's what you have right here. It's not as apparent, but it's definitely there. Any questions? So it's going to be A. Simplify the expression and state the restrictions of the variable. When you state the restrictions, it's only the denominator. Okay, so let's see. If we simplify this, what are we doing? When we simplify,
let's see what it could be.
Oops.
It is the x.
We got to factor the numerator and the denominator. So when we factor the numerator, this is the conjugate. S plus 6, S minus 6. We're going to use that as our fraction bar. The denominator is going to be S plus 8, S minus 6. You're going to cancel out the common factor. So simplified, we get s plus 6 over s plus 8. That's the simplified expression. Now, there are restrictions. What we're doing here is we're going to take the denominator. So this is denominator. We're going to factor it and then solve for the areas that the graph cannot exist. I don't need that. It's going to be s squared minus 2s minus 48, s plus 8, s minus 6 cannot equal 0, s plus 8 cannot equal 0, s minus 6 cannot equal 0, s cannot equal negative 8, s cannot equal 6. So those are the answers for the restrictions. Okay, so for this next one, domain means denominator. So you're looking for where, remember you can't have a 0 in the denominator. So it's x minus 9 equals 0, x equals 9. So this right here is a vertical asymptote. And it's also restricted. This is where the function does not exist. So then we have to use union in the domain. So the domain will have a union. So we're going to have negative infinity, comma, 9, union 9, infinity. This is our solution. It says, identify the isotopes. That means x and y. And then give your answers in exact form, do not round. So the way that a rational expression works is that you have the x-intercepts on the bottom, on the numerator, and you have the vertical isotopes on the bottom. So all of these are going to be your vertical isotopes. Vertical isotopes are x's and horizontals are y. So here's the rule. Vertical, you need to factor the denominator, right? Denominator. And then horizontal, you need to consider your cases. So we're talking about the exponents of the numerator denominator and what those mean. So then from here, we're going to say, let's answer the first part. It says equations of the vertical isotopes. It says separate multiple equations of isotopes with commas if necessary. Select none if applicable. Okay. Vertical isotopes, let's go ahead and factor the denominator. So the denominator is going to be x to the third minus 4x squared minus 9x plus 36. You have 4 terms. That means you're going to factor the first 2 and the second 2. I'm going to get x squared, so x minus 4. The second half is going to be negative 9, x minus 4. So then I get x squared minus 9 times x minus 4 equals 0. X squared minus 9 equals 0. X minus 4 equals 0. So then y'all like to do conjugates. We're going to factor this. Sometimes we're going to do square root. It's the same thing. So conjugates, x minus 3, x plus 3 equals 0. We're going to move this over. X equals 4. Again, we're solving for our vertical isotopes, or the VA. They all have their own equation. We have to separate this again. X minus 3 equals 0. X plus 3 equals 0. Move this over, x equals 3. Move that over, x equals negative 3. So we have 3 vertical isotopes. So it's x equals 3, x equals negative 3, x equals 4. That's the first part. The second part says
It's 18 hours.
8 equations of the horizontal isotopes and then equations of the slant. We don't have slant because we didn't do that on this section. Equations of the horizontal isotopes, we're going to take the cases. So we go back to our original function. I'm going to erase this. So we go back to our original function and we're looking at the leading terms and the isotopes. I'm sorry, the exponents, so that we can decide which case we have for the horizontal isotope. So the leading function here is going to be 2x. So I have 2x to the first. And I'm looking right here. And I'm looking here. And the denominator is going to be 1. I'm sorry. So I'm looking at 1 and 3. So the power of the top is 1. The power of the bottom is 3. Is 1 greater than, equal to, or less than 3? So it's 1 is less than 3. And I want to read my cases. Where the top is less than the bottom, my horizontal isotope is going to be y equals 0. So automatically y equals 0. And these are our solutions. This was a case 2. There it is all together. About the same. You're going to use Desmos to record the characteristics. Now, the characteristics of this function vary. I can tell you right now what the answer is. So the answer is this last one, but let's talk about it. We want to change this to like a dotted line so that it's a little bit more apparent for us. You got to press on it. Takes a second sometimes. Okay, and then let's do this one to another dotted line. All right, so again, it's apparent because there are dotted lines. So those are the equations of the horizontal and vertical isotopes. These numbers on top are going to be, the slider changed the number. Y'all don't use the slider. We don't need the slider in this class. So these numbers on top are going to be the x-intercepts, like it says, vertical isotope, horizontal, y-intercept. The idea is that our graph is going to go through all those x-intercepts and the y-intercept. And it's not going to, typically it's not going to cross the vertical or the horizontal isotope. So you're basically looking for what we call best fit. I know that these equations look very similar. That's just the way that it works. So to put in this fraction rational equation, what you're going to do is press the division key and then just type everything in. So it's x squared plus 3x minus 4. And then it's going to be x squared minus 8x plus 16. And again, these are hard to see. So if you collapse that equation, but lucky for us, it goes through every single point that it says it's going to go through because we've labeled them. So it's the line of best fit or the graph of best fit. Okay, that's it. Good luck on the next test.